Hello, this is a normal distribution question from October 2021. I'm going to show you how you can get full marks on this question, which is 8 and 11 marks in total. So we have the heights of females from a country are normally distributed with a mean 166.5 centimeters, standard deviation 6.1 centimeters. So given that 1% of females from this country are shorter than k centimeters, find the value of k. So we have our variable, is going to call it x. The height of the females is normal 166.5 and standard deviation was 6.1. So this is our distribution, and they are asking us what's the value of k, such as the probability of x being smaller than k is 0.01, 1%, right? 0.01. So what we are really doing is, let me show you. So if we have our normal distribution, the mean in this case, in this example, is 166.5. And we need to find a value somewhere here where this area is 1% or 0.01. So this is our k. So what we are going to do to find that value, because it's 2 marks, so we need to do some working out. You cannot go straight to the calculator and use the inverse normal, because that would be just 1 mark. If they are giving you 2 marks, you have to do some working out. So what we are going to do is to standardize this one. We are going to convert this normal distribution in a normal 0,1, so we can use the tables. Or you can use the calculator as well, but the tables I think is quicker. So we are going to standardize, and remember to standardize, we are going to call the new variable, instead of x, I'm going to call it z, because it's the letter that we use for the normal 0,1, smaller than k minus the mean. Remember to standardize, we are just coding the values. You take away the mean and you divide by the standard deviation. This must be 0.01. And what we can do is to go to the tables, and let me show you the formula booklet. So this is the formula booklet. Remember, you have a percentage point table where you have the probability of z being greater than a value, and we have the 0.01. So this table is tiny and has very few values, but if you have the value here, it's perfect. So this is 001, but we talk about values greater than a set, and we have smaller than a set. So remember, this is symmetrical. So if we think in the normal distribution again, this is symmetrical, and we are talking about normal 0,1 now. Yeah, so this is only for normal 0,1, this is 0. So if we are talking about values to the right, we are talking about this area here, but being symmetrical is the same that this area here. So if I have a positive value here, I have a negative value here, because the middle point is the 0. So if we are going to use this value, this is this positive one. As we need the area on the left, we need the minus 0.3263. Yeah, so this is the value that we are going to use, or that we need here. So this value here, that makes the probability 0.01, is minus 2.3263. Yeah, from the table. And from here, we just make that equal and find k. And k is 152.31 centimeters. So you have 1 mark for the working out and 1 mark for the answer. Yeah, so remember, if it's 2 marks, something like this, you cannot go to the calculator and use cumulative inverse normal distribution straight away. Although you can use it to check your answer. So you can go to inverse normal distribution in your calculator, use 0.01 as an area. This is the mean, and this is the standard deviation. You could do that. So this is A. Then for B, they say find the proportion of females from this country with heights between 150 and 175. Just 1 mark, so it's quite simple. This was A. So for B, I need the probability of, because they're asking me a proportion. Proportion is just the probability between 150 and 175. So I need this probability because that's the proportion of females. So I can go to the calculator. Lower value is 150, higher value 175, and this is just 0.915. So this is my proportion of females that are between those two heights. You can give the value as a percentage. That would be okay. See, let me say. A female from this country is chosen at random from those with heights between 150 and 175. So we are picking someone, but not for the whole country, just from that particular group. So that is going to be conditional probability because I'm restricting the space. I am between two values. Now I need to find the probability that her height is more than 160. So this, I'm going to do the next page. So for C, I need the probability that her height is greater than 160, given that is between 150 and 175. So I pick someone between those two heights, and I want the probability that a person is taller than 160. So conditional probability. On the top, these two things are happening at the same time. So is someone that is taller than 160, taller than 150, and shorter than 175. So it really is someone between 160 and 175. Yeah, and divided by this probability. So probability of being between 150 and 175. That is precisely what I just found in question before. Yeah, you just go to the calculator, you find this probability, which is 0.755. I rounded, but I recommend you to not round until the very end. So please just put the values in the memory of the calculator. And then this is the one that we just found, that was 0.915. And this is 0.847. Yeah, this is how many marks? 4 marks, no? 4 marks. Yeah, it's here. 4 marks. So the first mark is for the method. So this one is for the method. For knowing how to find the conditional probability. So for realizing is conditional probability, really. For using the correct method. For finding the correct values. And for the final answer. So 4 marks. They say the heights of females from a different country are normally distributed with a standard deviation 7.4. Mia believes that the mean height of the females from this country is less than 166.5. She takes a random sample of 50 females from that country and finds the mean of the sample is this one. Carry out a simple test to assess her belief. So remember, when we are doing hypothesis testing with a normal distribution, we are talking about the mean, and the mean has a particular distribution. So let me copy what we know so far. So we have a variable that is normal. I don't know the mean, but the standard deviation was 7.4. Yeah, and I observe 50 values, the real value, so the mean of the values was 164.6 centimeters, and I need to write a hypothesis testing, but we are talking about the mean of the mean of the observed values. So we are talking about this variable, yeah, not this one, but the mean. And the mean, remember that this distributed again as a normal. The mean is still the mean, and the standard deviation is the standard deviation of this one divided by so the variance is the variance of the first one, the variance divided by n. So don't get confused with the squares or not squares. When we put this in the calculator, when we put sigma, we have to put 7.4 divided by root of 50. Yeah, so let me write that sigma, which is what you put in the calculator, is 7.4 divided by root of 50. Yeah, so this is the one that we are going to test, the mean. So 80 is always with the equal. So we need to know if that's equal to 166.5. That is what she suspects. So not the observed value, but she thinks the mean height of the female is less than 166.5. So our 80 is going to be equal to that. And the H1 is going to be smaller than that because he believes it's smaller than 166.5. Yeah, so these are our hypotheses. What we are going to do now is to see if the probability of the mean being smaller, and remember this is going to be always the same. If we are in the left tail, it's going to be minus. If we are in the upper tail, it's going to be greater than. Is smaller than the observed value. We need to check if this is smaller than 0.05, which is our significant level. I'm sorry, I didn't copy, but the level of significance is 5%. Yeah. So we need to check if that's true, and then we'll decide. Probability of the mean being smaller than that value. We just have to go to the calculator. This is our normal distribution. If this is true, is going to be 166.5, and this same value here. I just know the mean now, so the mean is 166. We go with this to the calculator. We find this probability, and this probability is 0.0347, which is smaller than my significant value. Therefore, I have to reject 80. And if I reject 80, I will have to accept H1, or I have to say that Mia's belief, or there is enough evidence. I think that's better. There is enough evidence. There is enough evidence to support her belief, or something like that. Evidence to support her belief. Yeah, so remember, when you do hypothesis testing, always write the hypothesis, because that's 1 mark. Yeah, write the hypothesis, 1 mark. And they tell you. So most of the time they remind you, state your hypothesis clearly. But sometimes they don't, and still is 1 mark. Then you have another mark for remember that the mean is distributed this way. And then you have 1 mark for finding this probability. And the 4th mark is for your conclusion. Remember always to write if you accept or reject, or if you write a line like this, it's even better. Yeah, so these are the 4 marks of, so 1, 2, 3, 4, the 4 marks of this section. And that's all for this question.